Over the last couple of days, you've been solving systems of linear inequalities, and today I want you to be able to find the minimum and maximum value of a function that satisfies a given set of constraints, and we'll talk about what that is. So we're going to use what we know about linear programming to help us solve real-world problems. So first we're going to define a couple of vocabulary words, and linear programming is a method of finding a maximum or a minimum value of a function that satisfies a given set of conditions called constraints. Now we can actually call the constraint, there actually are inequalities. So an inequality in a linear programming problem we'll call a constraint. Then we have what is the feasible region, and that is the solution to a set of constraints represented by the shaded area. Now the last couple days you've been graphing, and I'm just going to put a little graph over here, graphing and shading. So let's say we had an system of inequalities and we shaded this over here. By shading, that means every point that is in the shaded area is a solution to that system. So it will work, each value for x and y will work if you substitute it back into the original system of linear inequalities. Now what we're going to do is, in addition to graphing linear inequalities, we're going to come up with the linear inequalities from a story problem. So what you want to do is you kind of want to take this apart piece by piece. We need to, step number one is identify an x and a y, because that's what you're going to use to write your inequalities. So as I read this story problem, Star's Bakery packages cookie gift boxes. They want their boxes to contain no more than 20 cookies. The marketing department conducted surveys and recommended that each box contain at least 4 sugar cookies, and they want no more than 12 chocolate chip cookies. So that tells me those are my 2 items that are in my box. So I'm going to let x equal the number of sugar cookies, and I'm going to let y equal the number of chocolate chip cookies. So what I'm going to do is I'm going to put these on my axes. So I'm going to put sugar cookies here, and I'm going to put chocolate chip cookies here. Okay, so we have identified x and y. Now let's go back into our story problem. They want their boxes to contain no more than 20 cookies. So they can have less than 20 cookies, but they don't want to go over 20 cookies. So we want the number of sugar cookies and the number of chocolate chip cookies to be under 20. So we can write that as an inequality as x plus y is less than or equal to 20. All right, let's put that in slope-intercept form before we graph that. If we subtract x from both sides, and I'll just write it over here because there's not a lot of room right here. So we'll subtract x from both sides. So that's going to be y is less than or equal to, subtracting x here, negative x plus 20. Okay, now what you want to do is you want to make sure you give yourself lots of points, because we're going to be, you'll see why in just a few minutes, why it's important to use lots of points. So we're going to start up on the y-intercept, which is at 20. And we're going to go down 1 over 1, down and over, down and over. And you're going to do this all the way across your graph. And especially if your graphs are have really small scales on them. And you should end up at 20 on the x-axis, 20 on the y-axis. So now we can go ahead and Our line's going to be solid because it says it's less than or equal to. And on these, I have several lines, so I'm not going to shade completely. I'm just going to say this is less than or equal to, so that means I'm going to shade below. So I'm just going to point this way. All right, so we've taken care of this information. Their marketing department conducted surveys and recommended that each box contain at least 4 sugar cookies, while the number of sugar cookies are represented by X. So I'm going to say X is greater than or equal to 4. Now we know that this is a vertical line. It has to cross the X-axis at 4. So let's go ahead and make that line. And this says greater than or equal to 4, so it's going to go this way. And we've taken care of that information. They want no more than 12 chocolate chip cookies. So chocolate chip cookies are represented by Y, so we're going to say Y is less than or equal to 12, which makes us have a horizontal line crossing the Y-axis at 12. So going all the way across here. So we've taken care of this. And another thing we need to consider is that we cannot have negative cookies. So if we were shading this, we would go down past into the negative number. So we have to say X is greater than or equal to 0. Whenever you're dealing with people or products, you want to include X is greater than or equal to 0, Y is greater than or equal to 0. Otherwise, you're going to get negative values. Now, when I do X is greater than or equal to 0, this time I really don't have to have it because when I go greater this way, it's already covered with this one right here. But we do need the Y is greater than or equal to 0 to stop from going into the negative numbers here. Okay, so I know this is going to be shaded this way. And I can now see my figure that's coming here. So I'm just going to shade it in. Now, what happens is any values that I pick inside here will work for my combination of cookies. So I could have 12 of the sugar and 3 of the chocolate chip. I can't have 12 and 12 because that's going to be outside of this area where all the solutions, so all of these pairs work. Now, when you're in business, you want to maximize profits or minimize cost. So the best solutions to maximize your profits are going to occur at your vertices. Okay, now, the objective function is the equation that you write to help you find out the profit. Okay, so, or the cost, depending on what type of a story problem you have. But since this story problem we're talking about profit, let's look and see where the profit says. Well, we get a profit of each sugar cookie yields a profit of 10 cents. So our sugar cookies are represented by 10. So we're going to say 0.10 X. Chocolate chip cookies, we make a profit of 15 cents. So it's 0.15 Y. Okay, now, since this is so small, I'm going to actually draw my table under here. Instead of using this, I'm going to write my V for vertices here. Or we can actually just put XY. That'll work too. And then our objective function is P of X comma Y equals 0.10X plus 0.15Y. Now we're going to take each one of these vertices, and we need to figure out which is going to give us, which combination of chocolate chip and sugar cookies will give us the most profit. So if we go to 40, that's one of our points. We also have, let's see, that's 412. And if we could keep going here, we have 812. And then we have 20. All right. So what we're going to do is we're going to take each one of these ordered pairs. This is the X, this is Y. We'll plug it in for X and Y. So for 40, we're going to have 0.10. X is 4. And Y is 0. And then we're going to find out what that total is. So this is going to give us 40 plus 0, so it's going to be 40 cents profit on each box if we have this combination. Now let's try 412. So 0.10 times 4. And that's going to give us 10, 15, and 12. So that'll give us a 220. And then we're going to try the combination of 8 and 12. So 0.10 times 8, that's our x, plus 0.15 times 12, which is our y. And that is going to give us $2.60 profit on that box with the combination of 8 sugar and 12 chocolate chip. And then we say 10 times 20, and that's just going to be $2. This turns into 0. Okay, now, in order to maximize profit, so if we're looking for the maximum, we need to look at the highest number here. Well, it's at 260. So our maximum value is 260. Just write it like this. And it happens at 812. Well, 8 represents the number of sugar cookies. 12 represents the number of chocolate chip cookies. So we will make the most profit if we have 8 sugar cookies in the box and 12 chocolate chip.